start with a little bit of overview. Thank you for the platform and to BBC Tech Meetup for allowing me to speak about IoT adaptation. Here we're going to learn about how a single connectivity skill has already served 90% of IoT applications. How is it to monitor, analyze, and improve IoT and not leaving out the 5 C's of Internet of Things. So a little bit about me. I'm a project coordinator at Strathmore University's Research and Innovation Center at iLab Africa, and I focus on the industry relations, linking it with the university. And other than that, I'm also a technical consultant where I assist companies and other organizations to deploy technological improvements, especially with Microsoft Office Suite and IoT developments. So the first thing that we always check with IoT is what is the definition of Internet of Things, and what are people or the standard bodies saying about IoT. And as we look through these definitions, we see that IEE says that network that connects uniquely identifiable things to the internet. ISO and IEC is an infrastructure of interconnected entities that includes people, systems, and information resources together with services, which reacts with information from the physical world and virtual world. And we can see that the common denominator with all this definition is that there has to be a thing, a connection, and also the internet. So once we go back to, we have various IoT ecosystems. And the first ecosystem that we focus on is technology. So IoT primarily exploits standard protocols and networking technologies. However, the most major enabling technologies and protocols are normally RFID, which is radio frequency identification, NFIC, and low energy Bluetooth or wireless low energy radio protocols or Wi-Fi. And so this network or this technology supports specific networking functionalities that are needed in an IoT system, in contrast to a standard uniform network of common systems. So if we look at something like how Wi-Fi Direct works, it eliminates the need of an access point, and it allows peer-to-peer connections with the speed of Wi-Fi and lower latency. And I would like to just give an example of one IoT system that deploys this type of technology. And we see here that the different ones we have is machine vision or optical ambient light. We have tilt, we have leaks, things that IoT can monitor. So for example, if you want to detect or use the sensor to actuate a floor for temperature, we have a sensor that detects the temperature or detects the heat, and then it sends this detection signal to a control center, and this control center sends a command to a sprinkler, and the sprinkler turns on to, for example, put out a flame. So when we go to IoT ecosystem, especially for markets, the market focus right now, or the market focus according to Gartner, is that it expects IoT to reach to about 170.6 billion USD. And this is just a compound growth that supports the coverage of Internet of Things by, for example, software solutions, services, platform applications, and various regions. And if we look into this little graph that I made, or little pie chart, it shows that who are the players, who are the main players in the IoT market. So we have people like commercial players and manufacturer producing smart appliances, home automation devices, and personal devices. And these are people like Amazon, Apple, Google, or Zigbee. And we also have online who provide IoT enabling services and applications. And as you can see, most of these companies, they are very versatile. So Amazon and Microsoft and IBM are still leading in those type of that type of commercial player market. Then we also have the academics. The academics are those ones who are focusing on educating a new generation about technologies of IoT and how to develop new ideas. And for example, in Strathmore University, we have an Internet of Things lab that focuses on the dynamic creation and application of Industry 4.0 and also Internet of Things. Then lastly, we have the government and utilities, falls under smart cities, where we have IoT devices like traffic cameras, security cameras, smart meters, smartphone tablets, etc. In the assist the government in education, transport, or any sector that requires tech or smart devices. And lastly, we have the business innovation where they develop cutting-edge solutions. So products like Google Glass or smartwatches and VR devices fall under this business innovation area. So the last thing in the IoT ecosystem is standards. So standards are simply a framework that help simplify the programming chores. And typically IoT frameworks are built on top of or otherwise utilize standard communications, protocols like TCP/IP, and they might be more specific in supporting or using IP version 6 of a low power wireless personal area network. And so this type of standards is now what we just defined above, which is IEEE, is that coming up with a common IoT definition that makes it easier to define components and common agreement on architecture that is used within the creation of data or transportation has become the major issue. And also the standardization process takes a while. So you can find that there are some types of products that need to have a specific timeline, and it takes longer to execute them or to bring them to market because of these set standards. So as you can see here on the diagram, we have the common protocols that follow the physical data link network, the OCI network protocol. And so various standards are applied through these various segments. So we will see the 5 C's of the Internet of Things. And the first thing that we want to start on is with consumption. So when you're developing or making an IoT system, the first thing that you need to, or the most fundamental stage, is to understand if you build these devices, are they capable of giving operational data so that is consumed into IT structures. And one of the major things that we always check is that you have to explore data with various volumes of IoT era edge computing that has defined or gained significant traction. And so the conventional model that we use to process or store data or data centers has been or has proved that it has been very inefficient and costly. And so now we want to focus on, if we make something, can it be used by people? Can they understand what their users are? And these are now, for example, we have the wearable health monitors, shipping containers, and logistics tracking, which heavily depend on IoT to improve their services. Then we have another segment of IoT, another 5C, and this is connection. So IoT connection or connectivity is a term that is used to define the connection between all the points in the IoT ecosystem. So these are things such as sensors, we have gateways, we have routers, we have applications, platforms, and other systems. So it's basically the different types of network solutions based on power consumption, the range, and the bandwidth. And various IoT projects require various requirements, and many of them use these different connectivity options um, depending on their needs. So we always say, why is the selection of the right IoT connectivity so important? Is because there is normally so much at stake. If you have to pick something that has to last longer in the market and the investment is not so costly, you have to consider either what type of connectivity. Is it satellite? Is it Wi-Fi? Is it Bluetooth? Is it internet? Then we have to go to cybersecurity. And as we all know, cybersecurity is such an important segment. And I can give, and it becomes internet that you used to, if you're milk or you don't have bread or etc, whatever you put in the fridge. So it becomes a link where a cyber criminal can now exploit your privacy, and it also covers the same as your phone or your laptop. So as an expansion, cybersecurity has a number of potential risks that IoT could be exploited through. And this can also compromise the data as we continue to watch the market grow. But ways that people or various companies have mitigated these cybersecurity risks is they have a general attack and detection or recovery system that is capable to cope with these IoT threats, and they also apply authentication and identification. So the difference between authentication and identification is that authentication will help you know you are part of the system, and identification will assist you to differentiate between two objects that belong to the same system. Then lastly, we have creativity. In a world where IoT devices are very pervasive and connected, many scenarios like the ones that have been previously mentioned can or are created by mimicking or seeing what human needs are. And as we get new lifestyle or new behavior changes, consumer needs also rise, and businesses also need to understand these needs. And that's why you see that so many companies right now are looking into relying in investing into a workforce that understands or can reimagine how IoT can be applied in various areas of their company or also their business scope. So lastly, we have compliance. And compliance is how people or processes and technologies that make up an integrated and deployed IoT system become compliant with some set regulations or best practices. And these compliance schemes are, for example, we have FCCC certification in the USA and the IC in Canada and the CE in Europe. And so many companies would like to understand or to get compliance tests so that once they deploy their products into the market, they have the right certification, the testing that has been done has been accredited, and also the product that has or that will be used is suitable for human in quotes consumption. So I will look at some case studies of where IoT has been applied, especially in Africa. And one of them, or as you can see the list, we have preventing oil pilferage in Tanzania. And we had, or there is still a company that is called Usangu Logistics, which was a transport company that had a fleet of over 100 trucks and tankers, which dedicated to distribute oil into various parts of Tanzania. But as they noticed is that drivers would often preferage this oil along the way and then will later sell the oil into the black market. And so they they came up with a lock system that is intertwined with a metal loop for the trucks. And then this shows and tracks what the drivers are doing. It also checks on the level of oil once it arrives, and it has worked so well to reduce the losses that they have been having for the companies. And then we also have the product verification in Nigeria, where they use radio frequency identification, especially to check or tag trucks which use a gateway device every 8 seconds, and the signal is sent to the main HQ offices for transportation. So this one assists them in curbing down things that are done with logistic areas where you find that there's drug counterfeiting and people are also selling or preventing distributors and wholesalers to continue in selling of stealing of these drugs or selling of them inside Nigeria. Then we have a recent application of IoT where was in Rwanda, and they used the robots that could help in minimizing the risk of infection for various health workers. And this would have done or is done by the robots would assist in checking the temperature of the patients and also would assist in delivering the food and medication and also capture data of various patients and assist in detecting abnormalities. So as you can see, there's some of the IoT applications is motion sensor, for example, temperature screening, that's a temperature sensor, and also identification of data. Then the last one is the Kenya, how Kenya uses IoT for utilities. So Safaricom, which is the largest telecommunication company, partnered with Kenya Breweries Limited to connect and enhance its coolers using Internet of Things. So by doing this, they connected the coolers and wired them with sensors to monitor the things of temperature and how often the fridge door will be open to determine how or give real-time data on how their drinks, for example, they normally sell liquor, how this beer is being sold or what exactly the shoppers who are given this fridge use it for. So to give an example here of IoT and smart cards, which has been something that people are exploring, currently they are in the world, 23 million cars globally connected with the IoT technology. And so this technology assists in giving auto insurance for companies that have or need automatic insurance. And also they provide, apart from insurance policy, you have things that you can monitor the area where your car is, see the surround view, parking assistance, and also blind spot detection. So this is just some examples of how IoT and smart cars work, because they get the communication and data and then they send it via satellite and cloud. And then this communication is then sent back for data analysis and communicated via either phone or iPad or whatever device that you are using. So we have some key insights on, especially from our research and statistics, big wigs. And you can see over there in Statistica, it represents the IoT adoption rate of the world as a breakdown in 2017. And we can see that industry products and electronics or high-tech and automotive, they lead the group because these are places where it's very hands-on and it's very imaginative, and it's places that they always have a value addition, especially for the Internet of Things. And if we look at what Gartner had displayed, especially in August 2019, we noticed that we have utilities which is rising, and by 2020, it picks up over there by 1.37 billion units. And then we also see that the government is buying into IoT, especially, for example, traffic monitoring, as we can see in countries in Europe, which are leading in this, building automation and physical security, which covers smart homes. So the adoption is very, very, it's actually growing, as I can say, because there's so much building of automation driven by the human need. Okay, so to conclude, I hope I've not been so fast, but anyway, to conclude, there has been a rise in activities geared towards Internet of Things, especially across the globe. And we can see that there's so much technology practitioners, business people, education institutions that are focusing on harnessing the value of IoT. And it has been predicted or estimated that by 2013, they were, or they still, I'm sure this is growing, 80,000, oh no, 80 things, 80 billion things being connected to the internet per second. And by 2020, it's estimated that there will be 250 things that will be connected to the internet. And with this massive number of interconnected things, businesses all over the world, as we can see, are very much repositioning themselves to tap into the huge potential that IoT brings for us. So with that, I think I've given a brief overview, but so we can have questions and answers. And you can also reach me on LinkedIn by Rosfina Barasa or on Twitter, Rosa_Rosie_B. Okay.